Hello, everybody. Wow. Hello, everybody.
Hello, welcome back to A Boring Revolution, your number one news source for everything in regards to the Boring Company. Thank you everyone for joining me this wonderful evening. And I've come back with a part 2 of one of my favourite topics, hexagonal segments. Now, just a precursor before I start the presentation, I possibly think that this is unlikely. It's unlikely that the Boring Company is going to use hexagonal segments. However, I think there is a damn good argument for using them. There's many ways to do this. I think this is the best way. There are plenty of other ways to do it. The Boring Company will probably use other systems. But why not talk about it? Because I find it interesting. And hopefully you do too. So, hexagonal segments part 2. There are many reasons most tunnels that are built in the USA or in Canada or in Europe or even in the Middle East or China don't utilize hexagonal segments. There's good reason they don't utilize it, and here are the reasons. Curved tunnel alignments cause segment erection and alignment issues. The main use for hexagonal segments is in water tunnels, and the main reason they're used in water tunnels is because they are very straight and they don't need to worry about all the issues that come with trying to make curved sections or even attempting to make curved sections with hexagonal segments. The uneven style of thrusting can cause point loading and ultimately stress fractures, and that is a biggie. I've become well aware of this now, that this particular issue is quite important to many engineers who use this system, is that you have problems with point loading. You get this phenomenon known as bird's mouthing, where basically you get a crack coming from the external corner as two segments are placed together, and then you thrust off them. And you start to notice this as you build the tunnel, and obviously that could lead to segments needing to be repaired. Potentially it could even lead to cave-ins if it's ignored. It reduces the air tightness, the water tightness of the tunnel. It's not a good problem to have. It's really quite concerning. But that problem can be eliminated with a bit of clever engineering. And I'm going to explain that today. Another reason is a lack of knowledge of the system compared to most others. It's just most engineers who work in the industry don't really have any experience of using it. And those that do probably haven't used it for a good while, or maybe they just specialise in it and the rest of the engineers focus on other systems. So there's not really that kind of knowledge there to understand the system and really improve on it. Individual hexagonal segments tend to be heavier than alternatives. Not massively more heavy, but just a little bit more to increase the cost and thus, make things a little bit more difficult when they are assembling these segments using the segment erector. Okay, so here is our kind of standard setup. This is rectangular segments. As you can see, it's a nice straight line, but if you were going around a corner, these ring beams here, as you can see, there's a few ring beams here. So for example, let's take this one. That ring beam could be packed out on the left-hand side, and then you could, it's like a salami. You can cut it in a certain way and then lay it out so that you get a curve. So this particular system works brilliantly on corners and always has, and there's very good reasons for that. And it just doesn't really make much sense to me to go away from a system that already works really well on corners. So we have our circumferential joints, which is basically the joints that run around the diameter of the ring beam, and then our longitudinal joints, which run essentially the length of the tunnel in intermittent positions. Also remember, we have these packers here. Packers are very important. Without packers, you would get uneven loading in between segments, and potentially again you'd get things like bird mouthing and pressure zones, cracks, that sort of thing, build up of tension in the actual segments. here is a hexagonal segment that was built as a bit of a mock-up to show the team how they build this. As you can see, it looks quite nice, quite a nice simple shape and structure. That's why I'm sort of gravitating towards this system, because it has everything that I believe Elon Musk likes, and it's that kind of simple but functional kind of design. In a straight line, look, it joins up perfectly. It looks good. It's got an interesting cross section, as you can see here. So these green marks here, they mark where the segments end. So we have 4 segments essentially, which join together to make each part of the tunnel, and then you add 2 at a time from there on in. So in a straight line, this system is really, really great. However, you get these stress fractures building up, you get issues with the segments. How do we rid ourselves of that particular issue? It has been brought up in the previous video that this should be a focus on straight alignments, and that's what I'm going to do. I'm going to focus on making this good in the straight sections, and then I'm going to focus on using our rectangular or our trapezoidal segments for curved portions of the tunnel. So this is an interesting cross section. You're probably asking yourselves, well, why have you gone for this kind of strange shape? And the reason is I'm attempting, there's many ways to do this, but I'm attempting to increase quite considerably the surface area of the actual cross section in order that I can transfer those loads down the tunnel without worrying about these stress fractures and this bird's mouthing phenomenon occurring. I've increased the surface area, but I've done so in a way that hasn't excessively increased the weight, because I could just increase the thickness of the segment and make it 500 mil, 550 mil, but it would become too heavy and too costly to use, and that's just a silly solution. This is more of a kind of cost-saving approach, which gives us the benefits of both worlds. So it increases the surface area, but also keeps the cost reasonably low. To make this work, you'd need concrete of 90 millimeter squared, M90 concrete, possibly higher than that. I've never seen M90 concrete used. The nearest to that I've ever used was a good 2 or 3 levels below that. So it's possible to make it stronger than that. I don't know what the drawbacks are exactly of continuing to increase the strength in the way that they do that, but it's possible and it can be done. We're going off point here a little bit, but as you can see here, this is where our thrust cylinders, or our jacks, actually push themselves off the segments. As you can see, I've got 4 jacks here. Now, normally it would look like this. So you'd have it like this, and then you'd have it on the other side here as well. So you'd have some on this side. And then you'd push off in 2 goes, basically. So you'd be assembling up here, and then up here, and whilst you were thrusting off on the left and right side of our illustration here. Now, what I want to do is I want to increase the thrust potential of the machine quite dramatically, but I want to do that in a way that's not going to absolutely destroy the tunnel segments that I've got lined up behind me. The main way I've done that is I've increased the surface area in these four points here. That allows me then to add 2 much larger thrust cylinders here. Now, these thrust cylinders are quite a bit larger than our other 8 here, around 160 to 180% more power per jack, maybe slightly more than that, and they can work in this area here. One point as well that I just want to note while I'm thinking about it is when you are assembling these segments, the gaps in between segments, for example this gap here in between a segment and another segment, that needs to be packed out perfectly. If that is not packed out perfectly, we might as well not bother going with this design. So the packing of segments, however they intend to do that, needs to be done very, very accurately. We're just going to focus on straight lines, therefore the actual segments themselves should line up very, very neatly. The number of pressure points therefore is reduced, and by packing things out properly, and these larger kind of enlarged areas here will make things a lot better for ourselves. So here you go. So this is what it'll actually look like. And again, this will be replicated on the top and the bottom as well. So you'll have these 4 large thrust cylinders, and then you'll have these 8 smaller ones, like the ones you see traditionally on standard TBMs. Another thing that's worth noting is the segment erector will need to be modified to take both these segments and our rectangular segments as well. And these segments will be heavier, so it'll need to be reinforced, which is a little bit of there's a little bit of cost involved in doing that, and there's a little bit of complexity, but it can be done. It's not an impossibility, but you're just going to have to take the hit on that one. A system like this, I anticipate, will massively increase the amount of segments that can be erected in any given hour, because you can push off, you can dig faster because you're applying more pressure to the face of the excavation. So that's all well and good doing that, but remember we've still got our issue with our curved parts of the tunnel alignment. We're going to get rid of, we're not going to bother using hexagonal segments in the curved sections. It just doesn't work. It's just, it's too difficult to play around with these segments the way that it lines up for curved elements. So what I'm going to do is I'm going to introduce a bridging piece. I'm going to explain that in a moment. Let me draw that again. So what a bridging piece is essentially is it allows you to transition from using your hexagonal segments and your long straights to then going into your rectangular or trapezoidal segments in your corners. The cornering or the curve of these alignments is not going to be very long. I'm going to try and minimize the amount of rectangular segments that I use by keeping these areas pretty minimal, as you can see by what I've done here. So I've drawn the long straight sections, which is like that and that, and then these areas here, this is where we've got a curved element, so I tried to keep that as short as possible. Again here, and again here, and again here, and then again here, and then again here. So as you can see, around 85% of this tunnel, if it were to be built, is hexagonal segments. These areas here, the 20% is rectangular segments. So it is going to be slower in the corners, but I don't need to worry about aligning my segments, and what I gain from doing that gives me greater speed down the road using my hexagonal segments. So I'm going to simplify the alignment. I'm really going to focus on making this tunnel much straighter than a traditional rail tunnel. I'm not interested in following any kind of guidance that is used for rail tunnels. I'm just going to focus on making it really, really straight, and then when I need to do a corner or change the alignment, I'm going to make it not super sharp, but you know, around 70, 80, maybe 90 meters in radius of the corner. Focus on my rectangular segments, get that done, install a second bridging piece, and then boom, I'm straight back onto my hexagonal. Speed, 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 speed. Focus on the speed and simplifying it. I'm going to try and keep the number of curves to an absolute minimum as well. I don't want curves. If I can avoid curves altogether, brilliant, but where I have to do it, I'm going to make sure it's quite a short length, and then I'm going to focus on getting that built quickly and then getting back into using my hexagonal. And they're going to be laser-like straight. That means that we're not going to have all these stupid pressure points, so it's just going to be full on. It goes together like a glove. The need for packing with this kind of system is going to be a lot less than with other systems as well. So it massively simplifies it by just using 2 different types of segments. Massively simplifies it. In terms of performance, so in these straight areas here, so like there, so I'd anticipate you'd be able to get 100 meters per day. So that's around a 20-hour shift. You'd get 100 meters. Yeah. in this area here, you're probably looking at around 20, 25, maybe slightly less, 20, 25, probably more nearer 20, I'd say. Then you get here, this is a really long straight here. You might even be able to get it up to 100, 120, maybe, possibly, in the long term. So I'm focusing on my straight areas, high performance. When I get to my corners, I'm focusing on keeping the length of that curved alignment as short as possible. And you can do that in the design phase before you've even gone on site or dug your first tunnel. So that is the approach. Bridging piece. So what am I talking about? So you have your hexagonal segment, and then you're trying to transition into your rectangular. Well, they're not going to go together, they're not going to mesh. So what you need to do is you need a piece that sits in between. Yeah, that piece is probably going to be made out of steel. It's going to be built to fit the perfect alignment of the segment. So essentially it goes in, you've got a dowel, various dowels, and then it's bolted in, fixed in. It probably takes 2, 3, maybe 4 hours to install that bridging piece. Once it's been installed, you can then start using your rectangular segments. Once you've finished the end of your rectangular segments, maybe you've got a curve, say, let's say the circumference of that curve is 80 meters. You've done your 80 meters, then you install another bridging piece, and then you can go back to your hexagonal segments. So it's like a transitional segment or a transitional ring beam. I don't know what word you want to call it. I think a transitional segment sounds better to me. It would allow the staggered use of both hexagonal and trapezoidal segments, but we want 80% of our tunnel to be, or at least maybe more, hexagonal segments, maybe 90%. If we can get it up to 90%, that'd be perfect. But where we've got curved alignments, we want to focus on trapezoidal or rectangular. Position in between curved and straight alignments, as I've just explained. Each transition beam or transition segment could range from 60 meters to 1,600 meters. So you could have massive distances in between your transition segments, or you could have, in certain circumstances, maybe you're trying to follow the right of way. I know the Boeing company wants to follow the right of way in Las Vegas. They could have them as little as 60 meters apart. And if that machine is capable of doing 20, 25 meters per day using rectangular segments, you can get through that 60 meters in about 2.5, 3 days. So it's all good. And then you can focus on your 100 meters per day with your hexagonal. I would recommend they're made out of steel, just because it's easier to prefabricate them, greater strength. They're going to cost more, but the fact that you can bolt them in and just drop them into place, and they'll probably be lighter than a reinforced concrete segment with equivalent strength. So I think, considering you're not going to be using that many of them, you might only end up using 20, 30 of them on a project. You might as well use steel, and you might as well have them built to measure, as it were. Okay, so the core strategy. This is how I think the Boeing company should approach it. As I say again, I don't think they'll use this strategy. This is my personal opinion, based on my 15 years, almost 15 years in the construction industry. Granted, I've never worked in the tunneling industry, but however, I do know the odd thing. So I think this makes perfect sense to me. This, I think, fits in with Elon Musk's strategy as well of simplifying. So we're going to simplify the actual route of the tunnel. We're going to have long straight sections, and then we're going to keep the curved parts as short as possible. We're not going to have all these kind of crazy different ways of doing it, because there are different ways where you could, jack the machine forward from the rear, and you could have, jacking arms that are coming out at 45 degrees, and it all gets very, very complex very quickly. And I think this is, based on my research, is just the simplest way of doing it, by having a different style of cross section, having more powerful thrust cylinders, and also focusing on the alignment and using bridging pieces. Play to your strengths and avoid weaknesses. So we're going to play to the strengths of the hexagonal segments and avoid the weaknesses of the hexagonal segments. And then we're also going to do the same for our rectangular segments. The strength of a rectangular segment is that it's really easy to form curved alignments with it. So we're going to use it in those curved alignments, but it's not that fast to assemble rectangular segments. So what we're going to do is just avoid using them unless we absolutely have to. Sacrifice cost for speed. Obviously, these segments have maybe 10, 15, maybe even 20% more concrete in them. A lot more rebar. Is going to be real, and it's all going to be a high strength C90 or M90 concrete. So it's going to be pretty hardcore stuff. The cost is going to go up quite a bit, but you're sacrificing a little bit of cost, not a huge amount of cost, just a little bit here and there, just to get massive gains in speed. Because the less time you're spending on site, the more time you have with that project making money, turning over money. So you're sacrificing a bit of cost for speed, but that speed then gives you a faster turnaround for that project. So in a way, it's not really costing you more. It's just costing you more in the short term. Increase both the increase both the thrusting capacity, and that is absolutely key. You can increase the speed of which the cutter head of the machine spins, yeah, and that is important, but the biggest difference will come from increasing the thrusting capacity of the machine when it's installing those hexagonal segments, because you can't use all your thrust cylinders or your jacks. You can't use all your jacks at the same time using hexagonal segments. You can only use half of them. So what you need is more powerful jacks to make up for the fact that you have less availability of jacks at any one time. In terms of the cutter head, you increase the torque of the cutter head, maybe increase it, 20%, 30%, 40%. That's all well and good, but you need to increase the thrusting capacity by, maybe 100%, maybe a bit more. So the focus needs to be on the actual jacks rather than increasing the amount of electrical power that you're giving the machine, in my opinion. Further refine the assembly process for both tunnel lining. So obviously you're switching between hexagonal and rectangular or trapezoidal segments. So you need to further refine that process of lifting those segments up using the erector and then installing them. That possibly can be fully automated, and I suspect it will. And the fact that you're using different segments shouldn't really make too much difference. You just have different software for each process, basically, or maybe the same software but modified. Use multiple TBMs at 7 mile spacing. So again, rather than having one machine that is doing 300, 400 meters per day, it makes more sense to me to have 7 machines that are all doing 120 meters per day, and you can get the project done a lot quicker. And if that one machine encounters a problem, that's bad news. But if one of those 7 machines encounters a problem, not to worry, because your other 6 can finish the rest of it, and maybe one of them could go and rescue it. Who knows? So it's all good. So that is kind of my opinion on that. Thank you so much for watching. I'd love to hear your opinions on what I've just been talking about. I think that using 2 types of segments on the same tunnel has never been done before. It's never been attempted. I can't think why. Maybe they've just thought that they could make rectangular segments better, and they never really focused on trying to transition between different ones. So what are your opinions on that? Do you think it would work? Do you think that the problems I outlined at the beginning of the presentation have been negated? Tell me what you think. I've had a long think about this for a good how long has it been since I did that last video? Maybe 4 or 5 weeks. This comes across to me as the perfect solution, and I can't really think of any major drawbacks for it. But I'd love to hear your opinions. Please join me on Discord, Twitter, and Instagram, and please like and subscribe to the video. Very important that you do that if you can, please. And give me some feedback. Thank you to all my lovely Patreons as well. You know who you are. Your names are on the screen now. Thank you so much for supporting me, as always. Great. Thank you so much, guys. So, that's the end of the presentation. Really enjoyed doing that. It's a lot of fun. We're coming up to the 26-minute mark, so I'm going to end. I'd just like to say thank you for everyone supporting the channel. Appreciate that. And remember, guys, don't be boring. We'll see you on the next one. Goodbye.
Excellent!
This is Sparta!